let's do functions and their inverse. So in grade 11, we did functions. So grade 12 is too simple. We'll always refer to grade 11. That's why we must get these marks, because we are doing something for 2 years, the same thing 2 years. So we must get maximum marks. In most papers of grade 11, 60 to 70% of the paper is grade 11 in grade 12. So we must maximize and get these marks, because we're doing the same thing for 2 years. We can't fail one thing for 2 years. So here, what they do in functions, they come and repeat the very same functions we did in grade 11, and they add an inverse. What is an inverse function? An inverse function is a reflection of that function along the line y is equals to x. So this is our Cartesian plane, and the line y is equals to x passes here. So let's say I have a graph. I have a graph, an exponential this side, and then if I put a mirror here, how will it reflect on the other side? That is an inverse. So it will reflect obviously in this manner, and that gives us a hyperbola. This is a hyperbola function. A hyperbola function has a reflection of the other half. This quadrant is reflected on this quadrant. That is an inverse function. So the inverse function is just a reflection of the original function. So in simple terms here, literally, we're just doing the same thing, just that we're doing it when it's standing upright and when it's standing upside down. So it's the same thing. So functions now, we have the parabola. In functions, the first one, we have parabola. What do you need to know if you're given a parabola question? What theory do you need to know? What concepts, what rules needs to be in your head? So first of all, we need to know, well, how does a parabola looks like? It's like the quadratic equation. So we denote as f of x or y, which is equals to what? In parabola, it's equals to a x squared plus bx plus c. This is the quadratic equation. This is the quadratic sequence. In sequence, we simply put n right here. And then we can also denote this function as a into x minus p, close the bracket, squared plus q. And another way, there's 3 ways to denote this one. We can also use another formula, a into x minus r1 into x minus r2. So when do we use these formulas? This one is the original. We use it anytime we want. And this one is the turning point formula. The turning point formula. If we have a turning point, if we have the value of the turning point, it's simple to use this one. Why? Because the turning point is negative, positive. P S to Q, that is the turning point. This P, this Q is the value of the turning point. So if we have the turning point, we already have the value of P and Q. We only have to worry about the value of A, and that simplifies our job. So then we need to note that the P, when it gets out of the formula to the Cartesian plane, it changes the sign. When it gets from the Cartesian plane to the formula, it changes the sign. And then when do we use the third formula? This is intercepts. If we have intercepts, and R1 is the left intercept of the parabola, R2 is the right intercept of the parabola. How do we get x intercepts? We equate y to 0. Y is equals to 0, solve for x, you get your x intercepts. The x on the left is R1, the x on the right is R2, and we only have A to worry about. So if we have intercepts, this simplifies our life. If we have TP, this simplifies our life. And rarely do we want to use this formula. Very rarely. We don't want to use this formula unless it's given to us. And then from there, we have TP again, turning point. We can use another formula to get the x value. The x value of turning point is equals to negative b over 2a. And then once I have this formula, where once I have the x value of turning point, I can then substitute the x value on my f of x that is given to get the y value. Then I have the turning point. When I have turning point, I can get the intercepts and another intercept and plot the graph. Then from there, what do we have? On parabola, this is all we need, and all this formula was derived. The turning point formula was derived from the original by using completing the square. We complete the square. So to complete the square, what is to complete the square? When you complete the square, you add and subtract the coefficient of x and square it. So you add and subtract the coefficient of x. Let's say we have our parabola as 2x. Let's remove 2. Let's just say x squared plus 2x plus 3. How do we complete the square on this formula? We come here and add the coefficient of x, the number behind x. 2, you divide it by 2, and then you square it. Then again, you subtract. You again subtract the coefficient of x and square it. Then from there, you decide that which one do you use for it to be a perfect square. We have a plus sign here. For it to be a perfect square, we need a plus sign. If we have a negative sign, once again, we need a plus sign. So it's usually a plus sign. We need a plus sign to get a perfect square. And then once we have got a perfect square, it will lead us back to this number. So I'm just not sure if my example can get to a perfect square. Let's see. X squared plus 2x, 2 over 2. Yeah, it gets to a perfect square. 2 over 2 is 1. Squared is still 1. So it will be plus 1. And then this 3 comes plus 3 minus 1. And then this is a perfect square. Why do we say it's a perfect square? Because when we factorize, we need the factors of c that will give us the value of b if added or subtracted. So now that will be x, and the factors of 1 that will give us 2 is 1 and 1. 1 and 1. How do we get 2 from 1 and 1? We simply add 1 and 1, it will give us 2. So that is a perfect square because it has repetition of the factors. 3 minus 1, that will be 2. So this is going to be x plus 1 squared plus 2. So if you notice this one, it's the same as this one. We have a as 1 because there's no number outside the bracket. We have p as negative 1, and we have the value of p. So you complete the square. This was done in grade 11, but many learners fail to understand this. So you must make sure that you understand how to complete a square, because we're going to do it once again when we get to analytical geometry. We're going to complete the square there. So please be comfortable with completing the square. The simple thing you do, the rules is that you add and subtract half the coefficient of x squared. As simple as that. And then from there, we have the hyperbola. This is the parabola from grade 11. Or let's just mix it. Let's mix it one time with an inverse. No, we'll do inverse soon. Let's not mix this. Let's just go on and do the parabola. There's some concepts I need to explain before we do inverse. So the hyperbola now, the same hyperbola we did in grade 11 comes back again. So why not do we get the marks? We should get the marks. So the hyperbola, the function y or f of x, it's equals to a over x minus p plus q. And then p and q here, they are not turning points. P and q, negative p. When p goes out to the Cartesian plane, it changes the sign. P and Q, these give me the asymptotes. They give me my asymptotes. P is the x asymptotes, Q is the y asymptote. So this gives me my asymptotes of the hyperbola. And then A, we just solve for A to get the value of A. And then there are formulas to get the axis of symmetry. The axis of symmetry on hyperbola is a line that cuts the hyperbola in half. So it's usually a negative one and a positive one. Those dotted lines we see in parabola, those are the axes of symmetry. So the axis of symmetry has formulas. Axis of symmetry, we've got formulas to get the axis of symmetry. So how do we get the axis of symmetry? To get the axis of symmetry, we can get y, which is f of x, is equals to negative x plus p plus q. Or we can have the positive one. The positive axis of symmetry is x minus p plus q. So you can use this formula. P and q is the asymptotes to get the axis of symmetry if they ask you to get the formula of the positive or the negative axis of symmetry. Or another thing we can do is that where my asymptotes intersect, the point of intersection of my asymptotes. So point of intersection on asymptotes, point of intersection of the asymptotes. On point of intersection, the axis of symmetry can be found by using the formula mx plus c. This is the original straight line function. So we come to the straight line function and substitute x and y, which is the value of the x asymptote and the value of the y asymptote. And then the gradient is either negative 1 or 1. If they ask you to get the negative gradient, the negative asymptote, the gradient is negative 1. Positive asymptote, the gradient is 1. And then we substitute y and c, y and x, then solve for c. That is if you forget these formulas, or if you do not want to memorize these formulas. Myself, I prefer this one because I didn't want to memorize these formulas, but they are quick if you memorize them. And then from there, that's all you need to know about the hyperbolic function. And then let's move on to the exponential function, which is very confusing to draw for most learners. But after this lesson, you definitely won't be confused. So the exponential function, the exponential function, we have the formula as y or f of x, it's equals to a b index x minus p plus q. And then the misconception, I will start with the misconception, is between a and b. How do we draw the exponential function? The exponential function can either be like that. This is an increasing function, or it can be like that. This is a decreasing function. It can also be in this manner. That is a decreasing function. It can also be in this manner, which is an increasing function. So what is the difference between a decreasing and an increasing function? From left to right, you just analyze from left to right. How is the graph looking? Is it going up or down? Are the y values going up or down? That is increasing or decreasing. So from this one, we can see that from left to the right, it's going up, 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 it's increasing. From left to right, it's going down, down, it's a decreasing function. As simple as that. And then now, when do we know that this exponential is supposed to be this shape, this shape, this shape, or this shape? So this is how you do it. When a is greater than 0, this is a greater than 0. Both of these, a is greater than 0. So I will divide these two. On the upper two, a is greater than 0. Why? Because the graphs are above the asymptotes. When the graph is above the asymptote, a is greater than 0. Then if a is less than 0, the graph will be below the asymptotes. And then when do we decide if it's a decreasing or increasing function? We need to intersect the value of b now. So if it happens in this case, a is greater than 0 and b is greater than 1, the graph will be like this. It will be an increasing function, a greater than 0, b greater than 1. Then for it to be a decreasing function, b will be less than 1. That will be a decreasing function. And then for this one, b has to be between 1 and 0. So in this case, a is less than 0 and b, let's say a less than 0, and then I need to check my notes here. It's also, I forgot the memory. A greater than 0, a less than 0, a less than 0, b between, increasing function. So it's this one, when b is between a less than 0, b between 1 and 0. That will be an increasing function. And then for a greater than 0, b, this one, b is greater than 1. b greater than 1, and that is my decreasing function. And I think there's something I mixed up here. A greater than 0, b between, decreasing function. The decreasing function, this one, a has to be between, b has to be between here. So we have b between 1 and 0 on 2 of them. And we have b greater than 0 on these 2. So just find a way to try and memorize these things, so that if you are required to draw, this question is very rare, it's not usual, but if it comes there, it's coming with 7 marks or something like that. So you need to know this so that you are able to draw the correct exponential function. And if it happens that you forgot these things, how then do you draw your exponential function? You come and substitute your values. You use the table method. The table method is x and y. Then you just come on your y, x, you put 1, 2, 3, 4, and so on. And then you substitute 1 on the formula. Let's say it gives us 3. You substitute 2, it gives us, let's say 6, and then this one 9, and whatever the value will be. And then this becomes your coordinates. Your coordinates. You make the coordinates and connect the dots. That's if you forget your form in this manner, but this is what you should know, because this is longer. This will save you time if you have memorized it correctly. Then that is your exponential graph, and q is the asymptote. The value of q is the asymptote. The value of p is also, it's not asymptote. P is not asymptote, but it's always there. It's just a vertical shift. It's just a vertical shift, but we do not have a vertical asymptote on the exponential. We only have the horizontal asymptote. And then now let's talk about domain and range. It's a very simple concept which we should not talk about, but then because people confuse it, we must. So on our Cartesian plane, the domain, and we end here. Let's meet again in another topic, and please remember to like, subscribe, and hit that notification bell so that you get more videos like this one.